Okay, here I'm back with full battery. Alright, the integral of 2x square root of x squared minus 5 dx. So I like to think that in my u box, alright, do you know what I'm going to put for u? It's going to be what's in the square root. And then my du dx is 2x, and multiplying both sides by dx, I get what du is. So, on this one, I see that I have a dx here and a 2x. So that's going to take the place of, du is going to take the place of this and that. And now I've taken care of this, and then I have the square root of u. Alright, so this is working out like the others. U to the 1/2. I know how to take the integral of that. So plus 1 gives me 3/2 divided by 3/2, which is the same as multiplying by 2/3. So I usually skip the divide by 3/2 and go right to the 2/3. Plus c, go back, put in my x values for u. U is x squared minus 5 to the 3/2 plus c. Alright. The complication I want to show is when sometimes the u du doesn't match the problem exactly. I don't think. Let me do one that still does. We didn't do a trig one yet, so let's try this. Can you foresee what's going to be the u value? It's going to be the value in the argument. So u equals 3x minus 1. And you know, it won't kill you to pick the wrong u, and you'll just see that the problem won't come out well. So du dx is 3, and multiply both sides by dx, 3 dx. So this 3 dx takes the place, du is going to take the place of the 3 and the dx. And we have left sine of u. But again, we know how to integrate sine of something. It's negative cosine u plus c. And going back to x's, u is negative negative cosine of 3x minus 1 plus c. Alright, now here's the next one I was alluding to. What if I have 5x plus 7 to the 20 times dx? So this one's not going to line up like the others. So I'm going to pick u in a similar way, and du dx is 5, and find out what du by itself is. I get a 5 dx. So notice there's no 5 in here. So I have my 5x plus 7 is going to take on the u, but the dx, I can't put a du here because it's worth 5 and there's no 5. So to make this substitution complete, I need a 5 in there. So it has to match. So I'm going to put a 5 in, but I can't just put a 5 in. I have to adjust for it by putting a 1/5 out in front. 1/5 times 5 is 1. So I have made no change at all. So this adjusts for putting in that 5. So now 1/5 times the integral of u to the 20th du. Now it's a perfect fit. But that 1/5 will come along and be in our answer. 1/5 times u to the 21st over 21 plus c. Let's go back to x's. So u becomes 5x plus 7 to the 21. 5 times 21 is 105 plus c. That wasn't that a snazzy trick. Alright. See if you can do this one ahead of me with the snazzy trick. Alright, x cosine 3x squared plus 1 dx. Alright, go ahead and pick your u. Alright, probably picked the right u by now, and it is that to which the cosine is applied. It's the 3x squared plus 1. So du dx, the derivative of that is 6x, and solving for du alone, you'll see that in my U-substitution box, du comes out to be 6x dx. So I have an x, I have a dx, but I need the 6. So I'm going to put it in here and adjust for it. I'm going slow, so hopefully you're working ahead of me. Alright, keep going then. So this, I'm putting in all the substitutions. I get cosine of u du. And everything is got its place. Alright, so what is the integral of cosine? Sine of u plus c. And heading back from u land to x land, sine of 3x squared plus 1. Alright, that's it for U-substitution. I hope that you were able to follow this and do this one ahead of me, and you will prove yourself to be strong in U-substitution very soon in class. So, till then, over and out.